Okay, welcome to this lesson, Mathematics Challenging Questions. That is what we are going to discuss today. And this discussion come after some of the students inboxed me or said to be some questions that give them a challenge. So we want to unpack the questions together so that at least they can get assisted. Even anybody who is watching this also will be assisted as well. I'm teacher Stephen Mudokech. The objectives for this discussion or for this lesson or this tutorial is by the end of this lesson, the learner or you should be able to solve the logarithms problem with the same basis and different bases. And also, you should be able to solve the 3 simultaneous equations using elimination method. Another one, you should be able to determine the determinant of 3 by 3 matrix. Let's proceed on. That is that. Sorry. The first question is that is log 3 minus x plus log 4 minus 3x minus log x is equals to log 7. So here, first of all, what we should be able to do first, get the range, define range for this equation, these logarithms. So for you to get them, the defined range, first of all, you will be able to get the argument of these logs. So if we begin with the first argument, that is log 3 minus x. The argument of this says that this log, this one is greater than 0. So 3 minus x is greater than 0. So that is the same as negative x is equals to negative, not, it should be greater than, the sign for greater than is that, is greater than negative 3. Then we divide both sides by negative 1 by negative 1. So therefore x is now less than, now we change, if you divide both sides by the negative, you now reverse the sign here, which is now x is now less than 3. So that is the first argument for this log. Another argument is for this log here. That is log 4 minus 3x minus 3x, that is also greater than 0. So 4 minus 3x is greater than 0. So therefore this 4 comes this side, we'll have negative 3. Negative 3x, I mean, is greater than negative 4. Then in this case now we divide both sides by negative 3. We divide both sides by negative 3. Very magnetic. So this negative 3 will cancel this negative 3. We'll be able to get x, because you have divided both sides by the negative. Now x will be less than, this also goes with that, is less than 3 no, 4/3. Then the last argument, we only deal with the argument where there is a known. For example, also this one, log x should also be, we take that is x is greater than 0. Now let's now get the defined range. In this case, x is less than 3, and also s is less than 4/3. And also in this case, x is greater than 0. So the range, that is the range of x, includes this sign in mathematics stand for inclusion. So it include that 0. It includes the digits from 0 to 3 over, no, not 3, but sorry, 4/3. So this is the range. To mean even this 3 is in between 0 to 4/3. So any value of x that we'll get, which is more than 0 and also less than 4/3, will not be considered correct. I think from there you have gotten that. Let's now go to the real working. We erase that, then we come to the real working. So the real working will now have log, so here log 3 minus x plus log 4 minus 3x minus 3x minus log x is equals to log 7. And this one, we said that the value that we are working for should only include the values which are from 0 to 4/3. So that is that, like this. So from here, we go to the rules of the logarithms, which says that if we add logs of the same bases, what we do to them, we now multiply. So we'll have log, we'll now multiply this times this one, which will be 3 minus x. We multiply by 4 minus 3x. 4 minus 3x, like that, minus log x is now equals to log 7, is now equals to log 7. So also we have a rule that say if it is a subtraction, then we now divide the logs if they are of the same basis. So we divide this log with this log, which can be written as log, that is log 3x, not 3x, but log 3 minus x. We multiply by log, that is multiply by 4 minus 3x. Then now we divide this by x. So this one is, we divide it by x, which is now equals to log 7, which is equals to log 7. So from here, we now drop the logs because they are of the same basis. These logs are the same. You now drop them. You don't cancel, but you drop. We'll have x. Now we remain with x. Multiply by 4 minus 3x minus 3x over x is equals to 7. For us to do away with the fraction, we multiply both sides by x. Multiply both sides by x. Multiply both sides by x. So therefore, what will we have? This x will cancel that. Now we'll be able to remain with 3 minus x into 4 minus 3x is equals to 7x. So this is the same as 3 into 4 minus 3x minus x into 4 minus 3x minus 3x is equals to 7x. So from there, we can now say that 3 times 4 is 12. 3 times 4 is 12. Minus 3 times 3x is 9x. Minus 4 times x is 4x. X, negative x times negative 3x, we get positive 3x squared is now equals to 7x. Is equals to that. Sorry. Is equals to that one. Now let's collect the like terms, this and that. So we can either begin with that because it will be a quadratic equation. We'll have 3x minus 13x. No, this is 3x squared, sorry. Minus 13x plus 12 is equals to 7x. So this 7 also can come this side. We'll have 3x squared minus, because if this 7 come this side, it also will be 9 minus. We'll have minus 13x minus 7, which is minus 20x. Plus 12 is equals to 16. Therefore, then we can delete that. Now we can use the factorization method to solve this. So the product is 3 times the 12, which is 36, and sum is -20. So we look for the two numbers. If we multiply those two numbers, we get 36, and if we add the same two numbers, we get -20. So those numbers are -18 and -2, like that, because positive negative times negative will get positive. So that is -18 times -2 will be able to get 36, and also if we add them, we'll be able to get -20. So let us see this. So now we'll have 3x squared plus minus 18x minus 2x plus 12 is equals to 0. So that is that. So now let's factorize this one like this. This one also like this. So what is common here is 3x. So 3x goes into 3x squared x times minus 3x goes into 18x 6 times minus what is common there is 2. 2 goes into x, 2x x times, and we have -2. 12 divided by -2, it will be -6 is equals to 0. Very good. Now we have x minus 6 minus 6 and 3x. 3x minus 2 should be able to give us 0. So therefore, we can say that x minus 6 is equals to 0, which is now x is equals to 6. Another one 3x minus 2 is equals to 0. Therefore, this one goes the other side. We'll have x is equals to 2/3. 2/3 like that. So from here, if we come to this range, now if we come to this range, now we exclude the value which does not satisfy this equation. We now exclude the value which do not satisfy this equation, depending on the defined ranges or defined range that we had defined earlier. So therefore, the correct answer here, therefore, the correct answer here is 2/3. So therefore, x is equals to 2/3. So that is the correct answer. So you ignore this one because it does not make this equation true, because this x6 is more than 0. So that is that. So that is how we should do that. Then the next one, The next question is that under the curtain or behind the curtain, sorry. So we have log x base 3 minus 4 log 3 base x plus 3. So the first thing that you do, you now say log x base 3 is minus 4 log 3 base x is equals to -3. So from there you can realize that these logs are of different bases. So what you do first, you ensure that you put these logs under the same base. So how can we do that? You can realize that this is log x base 3 and this is 4 log 3 base x. So let's make this log to be of base 3. We can use this formula that says that log x base a is equals to log x base b over log a, sorry, log a, no, log b, sorry, log b base a. Should be log b, sorry, log b, because they should be of the same basis. Log b, log a base b, sorry, it should be log a base b, like that. So log x base a is equals to log x base b over log a base b. In other words, how will this, so this one, you, to make it short, you always, if you want to change, make sure that those logs are of the same base, like this one, maybe to say y over log y, log of base y, like this. So then this x inakuja hapa, so itakuwa log x. Then this a itakuja huku ikuwe log a. So itakuwa log x base y over log y, no, over log a base y. So log x base y over log a base y. So that is what this log is the same as this log here. So that, so now let's change this one now. Let's change that one. So now we have log x base 3 minus 4 into, now let's change this log here to base 3. So what we do, we said we first write that base like this, base 3 over base 3, I mean, this one also log of base 3. So they are of the same basis. Then this 3 comes here. So we'll have log 3 base 3. Then this x comes here. So we'll have log x base 3. Just like that. Just like that. Just like that. Plus or is equals to -3. We had written it earlier. So realize that we'll have log x base 3 minus 4 into log 3 base 3 is the same as 1 over log x base 3. Log x base 3, which is equals to -3. So therefore, if we have this log and this log are the same, we now can say that let log x base 3 be y. So we'll have y minus 4 over y is equals to -3. So we can multiply both sides by the LCM, which is y. So y times y will have y squared minus 4 over y times y will remain with 4 is equals to -3 times y will have -3y. So this one is a quadratic equation. So we can write it in this manner. We'll have y squared minus 3y plus 3y now because it will cross the equal sign. Minus 4 is now equals to 0. So now here also we can look for the product. The product here is -4. The sum here is also +3. So the two numbers that if we multiply them, we get -4, and if we add them, we get +3, that is 4 and -1. 4 and -1. Therefore, we'll have y squared plus 4y, y squared plus 4y minus y was minus 4 is equals to 0. Now let's factorize this one. If we like that, like that, like that. So therefore, we'll be able to get you will be able to get the common factor here is y, which is y plus 4 minus 1 into y plus 4 is equals to 0. So we'll have y minus 1 into y plus 4. Y plus 4 is equals to 0. So either y minus 1 is equals to 0, which is y is now equivalent to 1, or y plus 4 is equals to 0. So now y is equals to -4. But we said that y, we said that log x base 3 is equivalent to y. So log x base 3 is equivalent to y, and y, the first one, we have gotten 1. So to mean, if you write this in indices form, where this one comes here, then this x replaces that one. So we'll have x is equals to 3 raised to power 1, which is just 3. Then we'll also get that another one was log x base 3 is equivalent to -4. So this one also comes this side, so we'll have x is equivalent to 3 raised to power -4, which can be written as 1 over 3 raised to power 4. So which is the same as 1 over 81, because 3 times 3 is 9, then 9 times 9 is 81. So then you come and say 1 divided by 81, you get approximate value of 0.0123 0 1 2 3 3 5 3 5, like that. So this one, all these values will be correct, because if we come and get the argumentative of each log here, where there is a known, we'll be able to get it here. We'll have log. If we come here, it is just the same as x is greater than 0. Then in this one, now you argue that here we have log 3 base x. So now the base is now equivalent to 1. So to mean x is now greater than 1. So from this case, we can say this thing, it is from 0 to infinity union 1 0 to negative infinity I mean, x is greater than 0. So it is 0 to infinity, then this side will be 1 to also infinity. So to mean it can be 1, 2, up to 1,000, more than 1,000. Infinity, there is no definite number. So you will realize that these ones will fall under same values there. Otherwise, that is that. And the next one is that says that you can pause the video. If you know how to do it, you can pause the video. Then you try doing it. Let's see. So for this, in this case, we can say this is equation 1. This is equation 2. This is equation 3. So in this, you can take any two pairs of equation, or you work out first, like the first one is 2x plus y minus 2z minus 2z is equals to 11. And another one we have 3x minus 2y plus 4z is equals to -8. So from here, we can, because we're told to use elimination, we can eliminate x by multiplying the first equation by 3, then the second equation by 2. So we'll have 6x plus 3y minus 6z is equals to 33. Then another one also will be 6x minus 4y plus 8z should be equivalent to -16, because 2 times -8 is -16. Then we now subtract the two equations. Well, this one will be equivalent to 0. Then we have -3y plus minus 4y. So it will be -3y plus 4y, which will be now y plus, not plus first, let's check out, minus. It will be minus. Delete this one here. Then we remain with minus, because -6z minus plus 8z will be -14z, which is equivalent to 33 minus 16 will be 33 plus 16, which will be 49. So now this one will be our fourth equation. Then again, you take another last pairs. Now you can take this one, the second and the third equation, where we'll be able to have 3x minus 2y plus 4z is equals to -8. Then we have x minus 4z. No, x minus plus 4y, I mean, minus 3z is equals to 15. Then the same, we eliminate x. If we eliminated x here, also this side we eliminate x. So here we multiply by 1, this side we multiply by 3. So we'll have now 3x minus 2y plus 4z is equals to negative 8. Is equals to negative 8. Then this one will be 3x minus, no, plus 12y minus 9z is equals to 45. And here also we subtract this equation. If we subtract them, we'll be able to get, that is, this x will be eliminated. So we'll have negative 2y minus plus 12. We'll be able to get minus 14y. Then we have also 4 minus 9. We'll have positive 13z is equals to negative 18 minus 45. You'll get negative 53. Then we can divide both sides by the negative, where we'll now have positive 14y minus 13z is equals to positive 53. So this one will be our fifth equation. So now let's work with the fourth equation and the fifth equation, where the fourth one we had for y minus 14z is equals to 49. It's equals to 49. Then we have also 14y minus 13z is equals to 53. I hope we have done it, everything okay. That 3y, 6y, 33, 6, 2, 4 is 8. This is a minus. So let's this side also we eliminate y, for example. So here will be 14. This side will be 1. So we'll have 14 y minus 14 times 14, 196 z, 196 z is equals to 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 . 49 times 14, 686, 686. Then here also we have 14y minus 13z is equals to 53. So therefore we'll be able to get negative, then we subtract. So we have negative 196 minus or minus 13 get 183. You get negative 183 z is equals to what, 686 minus 53. Get 693. Okay. So we divide both sides by negative 183 by negative 183 will be equivalent to, so we have the answer divided by negative 183. This thing, I think there is somewhere we have not done well. Let's see. So the first one, I said we take one equation, the two pair of equation like that one. We have 2x plus y minus 2z is equals to 11. This side also we have said it is 3x minus 2y plus 4z is equals to negative 8. So that is 3 by 2 is 6. 3 by 1, oh, the problem was here. Here is negative, but I wrote positive. It's positive, but I wrote negative. So hii itakuwa, so that is 3y minus 4, which is 7, negative 7, like that. No, positive, I mean, because it will be positive 3y minus, which is now plus, so it is 3 plus 4, which is 7y now. There is where we didn't get right. So to mean here is 7. Very good. So here also will be 7. So 14, let me erase this one. So that is that. We will have now 7 times 14. 7 times 14 is 90. So, okay, we'll have 7y plus that. Y is 14. 14. 14y minus 13z is equals to 53. So the first equation there will be 14 times 7, 14 times 7, which is now 98. 98 y minus 196 z is equals to 686. That is 14 times 49, 686. Then 14 times 7 also will be 98. Y minus minus 7 times 13, 91, 91z is equals to 7 times 3, 7 times 53, 391, 371, sorry, 371. So let's subtract. So we'll have negative 196 minus 91. We get negative 105. 105 z is equals to 686 minus 371. You get 315. 315. Very good. So here minus negative, divide both sides by negative 105. Divide both sides by negative 105. So z is equals to answer divided by negative 105. Z is negative 3. If z is negative 3, we can now get y using one of the equations here. So we'll have 7y minus 14z, and z is negative 3, and z is negative 3, should be equivalent to 49. Should be equivalent to 49. So 7y minus plus now 42 plus 42, because 3 times 14 is 42, is equals to 49. So this one here on the other side, so 7y is equals to 49 minus minus 42 is 7, divide by 7, divide by 7. So y is equals to 1. So then let's come up here. We'll pick one of the equation to get x. We will have 2x plus that is so plus y is 1 minus 2z, which is z is -3, so it will be positive 6 is equals to 11. This will be 7, so 2x is equals to 11 minus 7 will be 4. So divide by 2. So x is equals to 2. And that is the answer. And that is the answer for that. Find the determinant of the matrix A given this one. To get the determinant of 3 by 3 matrix, you multiply the coefficient of the row times the coefficient of the row, each row times its determinant, I mean. So therefore, we'll begin with these two. So if you take these two, you close this one, assume this one is now, this one does not exist, and also this one does not exist. So remain only with this one, these two. So it will be 2 negative 2 4 negative 3. So 1 positive negative. So this side will be negative. We go to this one now. If we go to that, that is 1 times the determinant of, so here we'll now close this one here. So we assume so let's remove this one. So now we have we go to this one. Now we tunaziba hii, we close this one. After that, then also we close this one here. So we remain with this, that. So it will be 3 4 1 negative 3 plus now come to this one, the last one. So this one also we close this one. We'll have to multiply with what will remain with here, which is now this and this, that and that. which is now 3, negative 2, 1, 4. So let's get the determinant in each. So determinant, that is this one, the main diagonal minus minor 1. So it will be 2 into negative 2 times negative 3 minus 4 times 4 minus 1 into 3 times negative 3 minus minus 1 times 4 plus that is 3 multiplied by 4 so there is 2 here minus 1 times negative 2. So this one is the same as negative 2, no, 2 in 2, negative 2 times 3 minus 16. No, negative times negative 3. That is 6 minus 16. 6 minus 16. We get 10. So 10 times that we get negative 20. Negative 3 times 3, that is negative 9. So negative 9 minus 4. We get negative 13 times 1, that is just negative positive now, times positive 3, 13 I mean. Then also we have 12 minus 2. 12 minus 2 is 1 will be negative 12 minus 2. That is 3 times 4, which is 12. 12 minus 2, get 14. Oh, sorry, there was a negative here. This one to mean here is negative. So here is also negative. That way. So it will be the 14 that we have gotten here multiplied by negative 2 is a negative 28. So this one is the same as 20, that is negative 20 plus 13 minus 28. You get negative 35. And that is the determinant. Thank you for watching. Thank you for watching, and kindly subscribe to my YouTube channel. So when we upload the next video, you'll be able to be notified. The only subscription is free. So kindly subscribe and share. with your friends so that they can get help. Any correction or any concern, just comment and be able to reply or do according to your wish. Otherwise, thank you and be blessed.